Welcome to my algebra class. We are on chapter 3, section 7. We are solving word problems, and there are going to be two unknowns, and they're of a certain type of word problem: cost, income, or value, or the coin problems. And we're going to again use charts to set these up to make our work a little bit more precise, easier to figure out what we have. So on the cost problems, they're going to give us the cost, the number of items, and the price per item. So when we set up our chart, we'll have two items, and we'll label those in the rows. And then the columns will be how many of each of the items we have, the price per item, and cost is always the number of items times the price. So that'll give us our total cost. Some of the problems will involve income, and to find income, you take the hours worked and times it by the wage per hour. So we'll have two items, probably two people working, and we'll have the hours they worked and the wages they obtained per hour, and then we'll figure out their total income by multiplying. And the third type of problem is a value problem. We'll have, this is for the most part the coin problems, we'll have the number of items, the value of each item, and when we times them together we'll get their total value. And we'll have at least two items, the number of maybe coin, like a nickel or a dime. So that's the general setup for these problems. Now we're going to do the evens. So you need your paper headed, full headings, skip a line, the title, page 127, problems 1 to 12. And fold your paper in half, and we're going to start with number 2. The chart's already made for number 2, so we could set that up right away. It looks like a cost problem, so we'll set up our chart. My pen's getting carried away here. So it says adult tickets for the game cost $4 each and student tickets cost $2 each. The total of 920 tickets worth $2,446 were sold. How many student tickets were sold? So we're looking for the number of student tickets. So we have the number of each type of ticket, the price per ticket, and we're going to have the cost. And the two types of tickets are adult and student. It said the adult tickets for the game cost $4 each. So we know adults were $4, and the student tickets were $2. There were a total of 920 tickets sold. Since we're looking for the number of student tickets, it'd be best, they didn't build on anything, but it'd be best to let X equal the student tickets, since that's what we're trying to find. And there was a total of 920 tickets, so if I took 920 minus X, that would represent the number of adult tickets. After I take away the student number, I have the adult number. So the cost per ticket for the adults would be 4 times 920 minus X. Use your distributive property. So we need to, I would pull up my calculator here and take 920 times 4. So this is 3,660. I think it is 680. Okay. Minus 4x, 4 times the negative x, and student cost is 2x. And it told us that the total of the 920 tickets was 2,446. So if I take 3,680 minus 4x, the cost of the adult, plus the cost of the student, 2x, it should equal $2,446. Collecting like terms, 3,680 and negative 4x and a positive 2x makes negative 2x. Subtract 3,680 from both sides. And again, if you want to use your calculator, no problem. We want to take 3, since the signs we're subtracting here, so the signs are different. We have a negative 3680, and we're going to subtract 2446 from that. That gives us, let's clear that out, 3680 minus 2446. That gives us 1234. So negative 2x equals negative 1234. Divide by negative 2, and we get x equals 617. And that was the number of student tickets. So we have our answer. There were 617 student tickets sold. By letting x represent what we were trying to find, we saved ourselves the trouble, and we didn't find the adult tickets, which in turn we would have had to subtract that answer from 920. So keep that in mind when we do the problems. Problem number 4. We have a chart again for this one. It's a collection of 52 dimes and nickels, and that collection is worth $4.50. How much were the nickels? So we'll make our chart, and since we're looking for nickels, if there's a way we can let x equal the nickels, we'll do that. This is a value problem. So we have the number of each item, the value of the coin, and then we have the total value. And the 2 coins that we have are dimes and nickels. And there's nothing built upon anything, and we're looking for the number of nickels, so we'll let x equal the number of nickels. They told us there's a total of 52 dimes and nickels, so if we take 52 minus x, that represents the number of dimes. So the value of a dime is 10 cents. I'm going to use pennies. And the value of a nickel is 5 cents. Using the distributive property, 10 times 52 is 520, minus 10 times x, minus 10x. The value of the nickels is 5x. So the value of the dimes, 520 minus 10x, plus the value of the nickels, 5x, has to equal $4.50. Since I was using pennies here, $4.50 must be changed to 450 pennies. Don't forget to fix that if you don't use dollar amounts. So collecting like terms, a negative 10x plus 5x is a negative 5x equals 450. Solving for x, undo adding 520 by subtracting it. So I get negative 5x, and since the signs are different, 450 from 520 is 70, negative. Divide by negative 5. So x equals negative divided by negative is positive. 5 goes into 7 once, and the 2 left over. 5 into 20 is 14. So there should be 14 nickels. And that is the solution. Problem number 6. We have Cecilia bought 12 apples, ate 2, sold the rest at 20 cents more per apple than she paid. Her total profit was $1. How much did she sell each apple for? Now this is a different type of problem involving profit. When we get to the equation, there's a specific equation, profit, and it's back in number 5. Profit equals the selling price minus the purchase price. So we're going to use that formula when we solve the problem. It's in number 5. So we have, for number 6, the number of each item, the price, and the cost. And the items are what we bought, and what we sold, because we're trying to figure out our profit. So it says she bought 12 apples. She ate 2 of them, so that leaves her 10, and sold the rest, so she sold 8. And she sold the rest at 20 cents more per apple than she paid. So since they're building on what she paid, X equals the price of what she paid, and she sold them for 20 cents more, so X plus 20 cents. So the total cost of how much she bought was 12X, and how much she sold her items for, use your distributed property, 8X plus 160. And here's your equation. Profit always equals your selling price, what you sold it for, minus how much you spent. And it said that the profit was $1, so we'll put, since we're using cents, we'll use 100. Her selling price was 8X plus 160. What she spent was 12X. So collecting like terms, 8X and negative 12X is negative 4X plus 160. Solving for X, undo the adding 160, subtract 160. So we get negative 60 equals negative 4X. Divide by negative 4. And we get 15. So the question is, how much did she sell each apple for? I discovered my error. I knew something was wrong. So she ate 2 of them. Then this should be 10. So I'll go back and fix this. This should be 10X plus 200. So we have the selling price is 10X plus 200. Now collecting like terms, you get negative 2X plus 200. The 10X and the negative 12X. Subtract 200 to solve for X. So we get negative 100 equals negative 2X. Divide by negative 2. And we get positive 50 equals X. So that was how much she paid for the apples, and she sold them for 20 cents more. So she sold them for 70 cents. Problem number 8. I have 8 more quarters and dimes. If the coins are worth $6.20, how many dimes do I have? So this is a coin problem. Make your chart. Coin or a value problem. So we have the number of each coin, the value of the coin, and the total value. And we have quarters and dimes. And it's set up, they're building on one thing, so we'll just go ahead and use it the way it is. They tell us that we have 8 more quarters than dimes. They're billing in dimes, so X is the dimes. X plus 8 is the number of quarters. We know the value of a quarter is 25 cents and the value of a dime is 10 cents. Using your distributive property, 25 times X is 25X. And 8 times 25, that's 8 quarters or 200. The value of the dimes is 10X. It's the weirdest spelling of dimes. So the total value is $6.20. So 25X plus 200 plus 10X, the value of the dimes, has to equal $6.20. So we want pennies, 620. Collecting like terms, the 25X and the 10X make 35X plus 200 equals 620. Solving for X, undo the adding of 200, subtract it. So we have 35X equals 420. Divide by 35, and we can use our calculator again. So 420 divided by 35 is 12. So X equals 12, and that's the number of dimes, so there are 12 dimes. And they wanted the number of quarters, so X plus 8 equals 12 plus 8. There were 20 quarters. Remember, the X plus 8 came from the chart up here. So our answer is 20. Oops, I'm sorry. They wanted the number of dimes. I keep reading the wrong problem. Just be careful. The answer is 12. Always go back and find out what they wanted. My mistakes are probably good because they're letting you know that you need to go back and double check. Especially if you look at the odds, it's answers in the back for the odds, and you know you didn't get that answer. Then go back and check to see what the problem asked for, because it's usually that is the mistake. Number 10, the Allen Company bought 80 tickets for a jazz concert. After giving away 20, the company sold the rest to the employees at half the purchase price. The company absorbed a $1,000 loss on all the tickets. How much did an employee pay for a ticket? This is a profit problem, and we have a loss, so this will be a little different. So it's set up similar to number 5 and 6. So we have the number of each, the price, and the cost. And we have what we bought and what we sold. So it said they bought 80 tickets. After giving away 20 to customers, they sold the rest to employees. So 20 from 80, they sold 60 to their employees at half the purchase price. So if X equals the purchase price, then 1/2 X equals the selling price. So the total cost, the total that they spent on buying this was 80X. And the total that the amount that they sold it for was half of 60 is 30X. Now remember, profit equals your selling price minus your purchase price. So the profit was a negative 1,000. They lost, so put a negative 1,000. They sold 30X minus the purchase price was 80X. So that's negative 1,000 equals negative 50. 30 and a negative 80 is negative 50. Divide by negative 50. And we get a positive 200 equals X. 20. So $20 is what they spent on the tickets, and the question that the book is asking is how much did the employee pay for the ticket? The employee paid half of that, so half of 20 would be $10 is what the employee paid. And the last problem is a wage problem. So make your chart. I think I have an extra line here. So this is the wage per hour, the number of hours worked, and the total wage. And the people working in number 12 is Raul for the weekday. So we'll just say Raul, and that's the week. And then on Saturdays, he worked at 8 hours at $2 more per hour on a week than on the weekdays. So Raul on overtime is basically what that is. So Raul he worked daily for 2 hours after school, Monday through Friday. So the total number of hours would be 5 days at 10. So he worked 10 hours during a week. On Saturday, he worked 8 hours. That's his overtime, at $2 more per hour than he did on the weekday. So they're building on the wage for the week. So X is his wage for the week. X plus 2 is his wage on Saturday. So his total wage for the week was 10X. Using the distributed property, his total wage for the weekend at Saturday was 8X plus 16. And it said he made $142 total. So the 10X for the week plus the 8X plus 16 for the weekend, the Saturday, has to equal 142. Collecting like turns, we have 18X plus 16 equals 142. Subtract 16 from both sides. We get 18X equals 126. Divide by 18, and it goes in evenly 7 times. So he worked for $7 an hour. The question is, how much did he make per hour on the weekday? He made $7 an hour. That concludes the evens. Please check each answer as you do the odds and get help as needed.